Let's talk about transformation of points. Alright, so I will show you with some DSC question on how to transform the points. Alright, some of the transformation being translation, some of the transformation being rotation. Alright, being rotation. So let's take a look at this question. Now it helps to draw the diagram. I doubt anyone can finish this question without drawing the diagram. The diagram is important, right? Even though if you don't draw it by hand, you have to have the diagram in your head. So let's say there are points P and Q. Point P is -3 and 5, so don't put in anywhere, right? -3 and 5 will be in the second quadrant like this. When X is -3, P is 5, Y is 5, alright? So that's roughly the position of P. And then we have Q. Q is 2 and -7, so where it is. 2 and -7 will be kind of like this. This is point Q. 2 and -7, right? It's important that you put them in the proper position. You don't have to be exact. You don't need a piece of graph paper to do that. But it helps to put them in the right quadrant at least, or the relative position. Alright, so point Q is easier. Point Q is translate to the left by 21 units to Q pi. So point Q is translate to the left hand side by 21 units all the way up to here. Right, so this is Q prime. Alright, so what is the coordinate of Q prime? We need to write down the coordinates of Q prime and P prime. Now to write down, you don't need steps, alright? Write down, no steps. You just state the answer, alright? So let's move 21 units to the left hand side. The x coordinate should subtract 21 while keeping the same y coordinate. In other words, it goes to -19, -17. -19, -7, sorry, it is a third quadrant point, alright? So both the diagram and the mathematics is telling you that it is a third quadrant point. So far so good, right? So this be point Q prime. Q is moved to the left by 21 units, so you subtract 21 from 2, keeping the -7 intact. There's no change in the y position. Alright. So let's look at P. Alright, people were making mistake in P rather than Q. So P is rotate anti-clockwise. Now anti-clockwise will be this direction. Alright, this is clockwise. This is anti-clockwise, ACW, alright? Be careful on the directions. Alright, so it is anti-clockwise through 270 degrees. So now, normally I will connect P to point O. And then I will do a counter-clockwise rotation by 270 degrees, right? This is the rotation. It's the counter-clockwise rotation by 270 degrees, alright? So the diagram is telling me it's going to the first quadrant. The first quadrant should be plus and plus. Alright? It should be plus and plus in the first quadrant. And then what else? We know that emergent, you have a rectangle right here. You have a rectangle, alright, going 3 and 5. So this is 3, this is 5. Now you flip it sideways so that the rectangle becomes this one. Alright, the pink rectangle becomes this one. So now with the original scale 3 and 5, I think this will be 3, this will be 5, isn't it? Because the rectangle turns sideways. Alright, so the coordinate should be 5 for the x coordinate and 3 for the y coordinate. And both, because it is in the first quadrant, so both x and y coordinate should be positive. So P prime goes 5 and 3. Alright, whereas Q prime goes -19 and -7. So these be the answers in part A, right? No steps, remember. Alright, when you have to write down the answer, you just state the answer. You just write down the answer, no steps. Alright, and then we want to prove that PQ is perpendicular to P prime Q prime. So we set up the relative slopes. We have the slope of PQ, we have the slope of P prime Q prime. Hopefully these two slopes they multiply to -1. Alright, so this is the way I write down the slopes. Let's see what are the 2 points. The 2 points are -3 and 5. This is point P. Point Q is 2 and minus 7, alright? So the slope will be minus 12 over 5. It's an awkward number, but let's see P prime Q prime. P prime Q prime, one of the point is 5 and 3. The other is minus 19 and minus 7, alright? The slope to this one is 10 out of 24. So they indeed multiply to minus 1. Alright, that's why the two, they are perpendicular. Alright, so this is the answer. So, anyways, part B is not important, right? It's about the slope and the perpendicular. What important is part A. How do you do the translation and how do you do the rotation of a single point, right? If you made a mistake in part A, you are not going to make it in part B, definitely. Alright, so be very mindful on this. Now, let's take a look at one more question, once again from the DSE paper on the transformation of points, alright? So once again, there are two transformations. One is an anti-clockwise rotation about origin. The other is not a translation, but the other is a reflection. Alright, so let's see how both transformations play out. So once again, let me draw the A and B point at the correct positions. So A is minus 3 and 4. Minus 3 and 4 is a second quadrant point. Alright, the x-coordinate is negative, the y-coordinate is positive. This is point A. So point A is rotate counterclockwise 90 degrees. Right? So this is point A. It is rotate counterclockwise. Counterclockwise, once again, is this direction. Counterclockwise, right? 90 degrees to another point here. So this is point A prime, alright? 90 degrees. So once again, I use my rectangle method. This used to be the rectangle with A. Now, with 90 degrees rotation, this rectangle is turned sideways, right? So what used to be 3 and 4 is now 3 and 4. Alright, we are turning the rectangle sideways if you do a 90 degrees rotation. Alright, so what used to be 3 on the x is now y. So A prime, the coordinate will be, x is in the third quadrant, so both are negative. So it is minus 4 and minus 3. This is A prime. Alright, A prime will be minus 4 and minus 3. So the quadrant is telling us the plus and minus for the x and y coordinate. We can roughly get the quadrant by drawing a correct diagram. Alright, and then let's look at point B. Point B used to be 9 and minus 9. So which quadrant is it? 9 and minus 9 will be in the fourth quadrant. X is positive, y is negative. Alright, now this one is reflected with respect to the x-axis. So it's go up. Alright, it's reflected with respect to the x-axis, not the y. If the y-axis, it will be here. Alright, but it is reflected with respect to the x-axis. We use the x-axis as the mirror. Alright, so this is point B. It's in the first quadrant, so we know both are positive. Alright, the x-coordinate does not change, so it is 9. The y-coordinate is flipped. Alright, minus 9 become positive 9. So this be point B. Alright, point B prime, I mean. Alright, so point B prime will be 9 and 9. Alright, so these are the answers in the transformation. And then part B is trivial. Once again, it's just like the previous question. We look at the slopes. Alright, A prime, B prime. This is how I put the slope. Right, I will draw this first, and then I will mark the 2 points. A is minus 3 and 4. B is 9 and minus 9. Alright, so the slope goes to 13 divided by minus 12, an awkward number. So that is the slope of AB. Alright, now for A prime, B prime, we have minus 4 and minus 3. And the other point is 9 and 9. Alright, 9 and 9. So this goes to 12 over 13. Alright, so indeed they multiply to minus 1. Alright, A prime, B prime is minus 1. So therefore they are perpendicular. Alright. So part B is important. What important is in part A. How do you do the rotation and reflection in this case? Alright, so these two are the DSE questions about transformation of a single point. We learned that in junior form. Also, the bottom of this page, there is also another question on the transformation of shapes. All right, instead of single point, now we have a shape. Now, these are all parallelograms. All right, so we want to investigate the rotational and refractional symmetry. Do we have refractional and rotational symmetry for these shapes? All right, so let's look at them one by one. For the rectangle, we have two axes of symmetry, refractional symmetry. You can reflect this one, all right? There is another one. The other axis of refraction is this one. But never mind, we just need one, all right? One is enough. So this is an axis of symmetry, so is this one, right? So that is a refractional symmetry for the first one. How about rotational? For rotational symmetry, there is a rotational symmetry because if you rotate this by 180 degrees, it's going back to the same rectangle. So there's a twofold refractional symmetry. So number one has both refractional and rotational symmetry. Number two, also refractional and rotational. Wow, in fact, there are four axes of symmetry for refraction in this square. Alright, so there is refractional symmetry, and there is also rotational symmetry. If you rotate 90 degrees, it goes back to the same square. So there are refractional and rotational symmetry in number two. Alright. Now, number three is a rhombus. It's a parallelogram with two sides equal, so it's a rhombus. For the rhombus, you have these two as the axis of refractional symmetry. And also, you have a 180 degrees rotational symmetry. It's a twofold rotational symmetry. Right? So once again, there are both refractional and rotational symmetry for number three. Alright, so the answer goes to D. All of them, they are correct. So the answer will be D. Okay? So that's how we work on shapes. We have when you translate, when you rotate, when you enlarge a shape, what will the new shape look like? Alright?